Welcome back, class. So we're gonna try example number one. So we're given a graph, and from the graph we are going to identify the horizontal asymptote and the vertical asymptote. So it's actually the easiest way to find the horizontal and the vertical asymptote is from the graph. We can easily, estimate it, right? But again, it's just an estimation. Later on, we're gonna do some algebraic form to find the vertical and horizontal asymptote given the actual function. So let's begin. So sometimes students get confused when they're trying to figure out which one's horizontal, which one's vertical. Personally, I always look at horizontal as being, imagine myself looking at the horizon, right? If you think about yourself looking at the horizon, how do you see the horizon, right? The horizon is like a straight line, right, that is laying down, right? So that's how I picture myself looking at the horizontal. So the horizontal asymptote is this line right here, right? Is this line right there. We can see there, and it's passing right through y equals 2. Remember, the horizontal asymptote is measured up and down, and we measure up and down by using y. So in other words, the horizontal asymptote is y equals 2. Can I give you guys a hint there? So we're gonna write 2. All right, so the next one is the vertical. So the vertical is going to be this line right here, right? We want to maybe mention that the function cannot cross a vertical asymptote, but it may cross a horizontal asymptote. I'll talk about that in a second. So the vertical asymptote happens to pass through x equals -1, right? So, and remember we measure x left and right. So that is x equals -1. So we're going to have -1 here. And then finally here the domain of the function. As we mentioned, the function cannot cross through this imaginary, vertical asymptote. So that means that the function does not exist there, but it looks like it exists everywhere else, right? It seems like this is going forever in that direction, so it's covering everything from here except here, right? And then the function continues, right? Right, by being defined everywhere on the right side. And you see how this is being defined on the right side by this graph. So if you guys think about it, if you want to maybe draw this picture, you can kind of see that it's just this number line at a -1. It seems like there's a hole, right? There's the function is not defined there. So you can probably think about it as being it's defined everywhere except -1, and then you jump from there and you restart over again your interval -1 to infinity, and then you use your union to define that. So I hope you guys find that helpful. Now I will come back and mention that you could have a graph that goes like this, right? Like it goes like this, and it just crosses the horizontal asymptote over and over again. But as you go to -infinity, it's getting closer and closer to y equals 2. So the function may cross a horizontal asymptote, but it may not cross a vertical asymptote.